Sorry, I take up your lunch time, so just take more additional 10 minutes to introduce my research about an on-site fishes image classifier system for poultry health assessment. And the course is Dr. Richard Gates from Iowa State University. And so the modern poultry farms, it contains, it's a little bit difficult. Okay. So the modern poultry farm contains thousands of birds in a house, which is very good for the production efficiency. But the dense poultry or bird distribution in a single house can increase the chance of pathogen transmission. And in 2015, the highly pathogenic avian influenza outbreak hit the poultry market in the United States and Canada. The initial clinical sites on Canadian poultry farms were observed on November 26 and 28, but the official farm quarantine happened on December 2nd, and finally leading to the depopulation of over 48 million birds. And there were at least 5 days gap between the initial clinical size and the actual action taken to prevent the situation being worse. And now the HPAI still stalking the U.S. poultry market again. So we think whether we can develop a system that can detect the poultry health problems earlier so that we can reduce the producer's economic loss. So there is urgent need for developing a rapid and accurate health assessment tools. And the poultry feces are direct measures of the health status of the digestive system for poultry. And I think we have a lot of speakers talking about something about the testing of the disease in the lab or on the fields. That's the gold standard way to test the poultry disease on the farm or in the lab. But now there are some alternative methods like feces image classification methods that can provide some non-contact and rapid measurement methods. But there is currently no mobile poultry health assessment tools available for the producers. Therefore, the objective of this research was to develop a mobile application for on-site poultry health assessment using the deep learning-based computer vision techniques, Internet of Things, IoT, and mobile application app program. So we use open access image data set collected from small and medium scale poultry farms for classes that were healthy, coccidiosis, Newcastle disease, and salmonella. A total of 6,812 images were used. So we can see the healthy birds, they typically have some solid feces, but the birds infected with the coccidiosis, they will have a liquid and fresh yellow feces. And the bird infected with Newcastle disease would have liquid disease liquid feces with mixed colors of green and light yellow. And the bird infected with salmonella would produce the feces that contain white liquid. So based on this feature, we do the analysis. So 6 deep learning models were comparatively evaluated to determine the optimal ones. These were VGG16 and ResNet and Insection, MobileNet, DenseNet, and EfficientNet. And we add additional layers on top of each networks. So that's a kind of transfer learning technique. So we don't need to train the models from scratch, but at the same time, we can get enough accuracy to do the poultry feces classification. So this table shows some the architecture of the additional artificial neural networks structure. And for the model development strategies, we use cross validation and data augmentation. And the system has some key components, the app, IoT, and computer server. So it's kind of simple. Like if we take the image on site, and then we select the image from the phone album of our phone, and then the raw image will transfer from the router to the computer server, and then the deep learning model will process the image and then return the processed image back to the phone so that the producers or the farm manager can see the result in real time and know what happened. And this is the performance of different models for poultry feces image classification. And we finally select the MobileNet V2 with additional layer of artificial neural network because it can classify the poultry feces image accurately. And meanwhile, it processes each image faster than the other models. Uh, this is the interface of the app. So we can see we have a home page. When you open the app, you can see the home page. And if you select the process image button, you go to the upload page. You can see the gray button here. And then if you click on the upload an image button, you will upload the image. You will select the image and transfer to the computer server. And then after the processing, the image transfer back to the app. You can see I don't know how to see. Okay, so you can actually see the label name here. That's the coccidiosis. And then there's an additional function for that. Like if you click on the share button, you can share the process results to the veterinarian or the production manager so that they can take action timely to stop the situation. And this is the website or the computer server. So for the website, so it can assign different usage credentials for different levels of users. For regular users, they can only upload or save their projects. But for some administration users, they can create new users, they can delay the users, they can delay the projects. So this kind of hierarchical management method would help us to assign some usage of credential to the trusted users. Meanwhile, we can maintain the system function. And the website can also save projects, save user information, and load classification models. So actually, I need so this system involves a lot of programmings, which I do not want to mention here because it's too technical. It involves like JavaScript, Python, or other type of language. It's a whole package of programming. So as for the final performance, you can see the result is not bad. So it can classify the 4 classes ranging from with the accuracy ranging from 82 to 96, and for the processing speed, so it's most likely less than 1 second. And as for the conclusion, the MobileNet V2 was selected for the classification, and the system was developed to achieve the automatic on-site poultry health assessment. And the poultry health assessment system had 90% accuracy and processing image in less than 1 second. So I think I will have additional time. So thank you for your listening. I will take any questions.